Good morning, grade 7s. My name is Siseko Ntuli. I'm here to present transformation geometry with you guys. So we will be having our session based on transformation geometry. I thank you. Right, then let us get to it, guys. It's a very interesting topic, very nice. You will see when we go on that it's quite an easy topic to master very easily and to understand. Now let us get to it. As I've said, we are going to be presenting, I'm going to be talking about transformation geometry. The lesson outline is as follows. First of all, we've got to define what is transformation. We've got to familiarize ourselves with the vocabulary that is used under this topic. What are the resources that we're going to use? We're going to touch on the resources that you need to have so that you can be able to successfully complete and understand this topic. And then I'll be doing demonstrations with you guys, and then we'll tag into translations, rotations, and reflections. Therefore, each and every part, especially when you talk about translation, rotation, and reflections, we're going to show you activity. We're going to demonstrate and do activity together so that we understand what is required of us when we encounter such topics in the test and exams, and we understand it so that whenever we go to the next class, we now know what does it mean to translate, what does it mean to rotate a figure, and what does it mean to do a reflection of a figure. Right, let us get to it, guys. So the first thing, the question is, what is transformation? In simple terms, it says transformation is a change in position and or the orientation of a shape. Is a change in position or the orientation of a shape. So we've got to understand that, okay, when we talk about transformation, we are talking about a change in position or the orientation of a shape. It may be, it will depend as we go along, how will that change take place. Then what could be the vocabulary that we will need to familiarize ourselves with under this topic? We're going to talk about rigid transformations. Guys, our scope is based on only rigid transformations. So we're going to be talking more on rigid transformations. We're going to talk about what is an object and what is the difference between an object and the image. What is translation? What is line of symmetry? I'm sure, guys, this item where we talk about line of symmetry, we've encountered it before when we were doing grade 5, grade 6. So in grade 6, we spoke more about lines of symmetry. Now again in grade 7, we still talk about lines of symmetry. We cannot leave lines of symmetry when we talk about transformation. And then we're going to talk about reflection. What is a reflection? And when we're going to talk about rotation, we're going to understand what is a rotation. We're going to know what is the point of rotation, what is translation, what is prime symbol, and then what does it mean when you say figures are congruent figures, and line of reflection, and then we're going to talk about vertex. What is a vertex? So in essence, in short, guys, this is a vocabulary that we need to familiarize ourselves with when it comes to this topic of transformation. Now let us get to it. Rigid transformations. We say a rigid transformation is a transformation in which size and shape do not change. In other words, when you say it is rigid, it means that the size or the shape of the figure will not change. It will stay as is. So the size and the shape will not change. That means it is a rigid transformation. Then, what is an object? The object is the original shape before transformation. You will see somewhere along when it takes place that we will be given a triangle, which could be an object, which means the original shape before a transformation. And then we're going to encounter an image, and what could be an image? An image is the shape after a transformation. So after we did our transformation, we're no longer having an object. We've got an object together with an image, or we've got an original figure together with an image. The image is the one that has been transformed. And then we're going to talk about translation. A translation is a transformation in which a shape moves left or right or up or down without losing its size or shape. Is a transformation in which a shape moves left or right, or it may move up or down without losing its size or shape. That is what we call a translation. Does not move diagonally, only moves up or down or left or right. Then rotation. A rotation is a transformation in which you rotate or turn a shape. So think about the arms of the clock. They rotate. They rotate. So that is what we talk about when we say rotation. And then point of rotation. Point of rotation, the point around which a shape rotates in a rotation. The point around which a shape rotates in a rotation. Like we have seen in the arms of the clock, a watch there, all those three arms are connected in a particular point. Now, that point is a point of rotation because they move along that point, all of the arms of the clock. So we talk about a point of rotation. Then, order of rotational symmetry. The number of positions a shape can be rotated to without making any changes to the way it looked originally and get back to its original position. Yes, as you have seen most of the time, the arms, I will make an example of the arms of the clock. As it rotates clockwise 360 degrees. So we're talking about order of rotational symmetry. The number of times the point will be rotated without any changes to the way it looked originally. Then reflection. Reflection, a mirror image of a shape that has been reflected. A mirror image of a shape that has been reflected. You normally see yourself when you look in the mirror. That's your own reflection. So reflection is basically about that. So just remember yourself or imagine yourself looking in the mirror. The person you're seeing in front of you is facing you. So that is your own reflection. So we're going to be talking about that as well. Line of symmetry. A line of symmetry or axis of symmetry is a line that divides a figure into two parts that have an equal number of sides, and all the corresponding sides and angles are equal. A line over which the shape is reflected. This is also called the mirror line. So you will see more when you talk about that line of symmetry when it gets to reflections. Prime symbol. A prime symbol is a sign allocated next to each letter of an image, not an object or original shape. Or we talk about an image, e.g., the object has letters A, B, C, and the image will have letters prime A, prime B, and prime C. So most of them, they will have these markings just on top there. Though that means that this is the translated part of a figure. It is no longer an original object which does not have those markings on top. So these markings, they mean that now this is a translated or a transformed figure. It may be translated, it may be rotated, it may be reflected, but the symbol will have a prime, so we'll call them prime symbol. Then we have congruent figures. What is a congruent figure? Congruent figures are figures that are the same size and shape. All the sides and angles of the figure match. Careful there, guys. What is most important is that figures are the same size and shape. Size, it means that even if inside the shape, the angles there, they should be equal. And the size around the shape, they also must be equal. All the sides and angles of the figure match. So the last part there is a point, a vertex. Vertex is a point or a corner of a shape. So when you talk about a vertex, you talk about what? A corner of a shape or a figure. Right. Now, let us touch on what resources do we require to be able to successfully complete a transformation, guys? First of all, we'll need to have a grid paper. A grid paper is a paper like this one. Is a paper like this one. So this is a grid paper. That is the first thing that we need to have as one of the resources that we'll be using under this topic. And then what else? We'll need to have a ruler. You may have your 30 centimeters ruler or the one you are taking out of your mathematical set like this one. So this is a 15 centimeter ruler that comes out of our mathematical drawing instrument. All right. Then we need to have pencils. We may have long ones or even the short ones. We need to have pencils. This one is already inserted inside the compass. Inside the compass, so we need to have this as one of the resources. And also, we need to have different colors. Myself have been provided with these colors differently so that we may make our work colorful and understandable easier. And also, we need to have a mathematical drawing instrument. So it may be any of your mathematical drawing instrument. So we need to also have it as the resources that we're going to be needing in order to successfully complete this unit, guys. Right. So guys, after we have identified the vocabulary that we're going to be using most frequently and also what are the resources that one needs to have in place, now let us get to the business of the day. Right. Now, translation. We're going to talk about translation, guys. Now, let us see. We've got a shape there which is in a form of H. And then it shows that it has been translated to the same shape, but now it is labeled J. Or you may translate a figure in a graph. Like we can see there, we've got triangle EGF or EFG. EFG, it has been translated to triangle prime E, prime F, prime G. Now, when you take a look, there was no change in size. The size did not change. The distance between the points did not change as well. So it was only translated. So this is typical picture that we're going to come across. In fact, we are going to do them together so that we understand how do we then translate the shape. Right. Let us get to it. Right. Exercise 1. Let us try it and put it in practice. It says, in translation, all points on the figure move in the same direction by the same distance. Now, let us now look at the triangle ABC. Triangle ABC. Triangle ABC. Right. So this is triangle ABC. Triangle ABC. Now let us look at it. It says, copy the triangle on the following page, which is this page. So we're going to copy this triangle. Translate each point ABC 5 units to the right and 2 units down. First, before we can translate. Let us start copying this and see how it's done. Right. Right. Now let us look. I need to copy this. Ne? The first thing that I'm going to do, remember, I will draw a line here because I need to put my shape underneath here. So I will draw a line here. Now, now I'm going to count. Remember, C there, you see there is this space here on top. I need to also leave this space on top. So it means that there is one space or one block that they were left there. So I'm going to count how many lines before I can draw, I can point the shape, the C there. Now, let me see. Let me count here. They skipped from here. They said 1, 2, 3, 4, 5, and in number 6 they have got their point C. So I'm also going to follow the same route. I'll see 1, 2, 3, 4, 5, and in number 6 there I will have my point. I'm copying it. So here will be my point. Let me make it red. Right. And then from point C to point B, I will count how many lines. Here's point C, so I won't count this line. I'll say 1 and 2. In other words, from here I'll say 1 and 2. It will be my point B here. Right, from point B, how to get to point A? From point B, I skip 1, 2, 3. On the fourth is my point A, so I will count 1, 2, 3. Number 4, it will be my point BA. My point A. Then, after having done those 3 dots, then I join them. I'm going to join them as per the instruction. So I'm going to join them. Right. Now, here it is point C. Here it is point B. Here it is point A. Now I copied it. Let us check the other instruction. What does the instruction tells us? Right, it says here, translate each point 5 units to the right and 2 units down. 5 units to the right. So we are told to translate each point 5 units to the right. Let us start with point C. Here is our point C. Now we need to translate it 5 units to the right. So we will count 1, 2, 3, 4, 5. And 2 units down. 1, 2. So it means our prime point C. Here it will be our prime point C. They said we should translate 5 units to the right. So right is this direction. So we'll count again 1, 2, 3, 4, 5. And then they said 2 units down. 1, 2. Each point. So we only translated C now. We need to translate B. Let us go to B. 5 units to the right, 1, 2, 3, 4, 5, and 2 units down, 1, 2. So our new point B or prime B here, B prime, will be here. And then let us translate point A. It will be 1, 2, 3, 4, 5, and 2 units down, 1, 2. There we have A prime. After that, the instruction says there, then join the translated points to form the image triangle ABC. Now let us join these points. Now we need to join these points. I'll join point C with point A, point C with point B, and then I will join point A with point B. Therefore, I have translated this shape. Let me check the instruction there. Look at the completed translation. So here, can you see there, guys, there is a difference? Remember, this one is an object. This is the original shape that was given to us. This one is an image. So the image will have A prime, B prime, and C prime. Means that we have translated as per the instructions from our exercise set, 1, 2, 3, 4, 5 units to the right and 2 units down. 1, 2, 3, 4, 5 units to the right, 1, 2 units down. And same as A, 1, 2, 3, 4, 5 units to the right and 1, 2 units down. So we've got an object, we've got an image. So we have translated all the points, and after translating the points, then we join them. So very important there, guys. First thing, translate the points as per the instructions, then you may join them afterwards. You may not translate the whole shape or the whole figure there. You can only translate the points first. The points we're talking about, the vertices of each of the following shape. So these are the points that we are talking about when we say translate each point. So you translate each point as per the instruction. If it says 5 units to the right, you translate this point 5 units, and this point 5 units, and this point 5 units, and then 2 units down as per the instruction. So we have successfully translated. We have successfully done our first translation, guys. Right. Then it says, look at the completed translation. Are the side lengths of the original triangle and those of its image the same? Let us check. They are asking the side lengths, are they the same? Meaning, are they equal? Let us check. Let us use our ruler there. Normally, I would use centimeters, guys. So let us check the distance. So when you check there, you can see here we've got 4 centimeters. Or almost 4 centimeters, yes. From point A to point C, it is 4 centimeters. Let me just write it for interest's sake. 4 centimeters. And then from point C to point B, we have 1,8 centimeters. And then from point A to point B, we have 3,7 centimeters. Now, they asked us to check whether the side lengths of the object, are they equal to the side length of its image? Let us check the image. The image from point A to point C, we have 4 centimeters as well. The image from point C to point B, we also have 1,8 centimeters here. And then from point A to point B, we have 3,7. So the answer there is that are the side lengths of the triangle and those of its image the same? The answer will be yes, they are the same. We have just measured them. Is the area of the original triangle the same as the area of its image? The space that is covered here, the space that is covered here by this object is equal to the space that is covered by its image, which means our answer is yes as well. So what we are learning there is that when we translate a point, the side lengths of its object will not differ, will be the same as when you have translated and have an image whereby you've got A prime, B prime, C prime. Right. Right, guys, let us move along. Let us try this exercise number 2 now. Exercise number 2, it says, on a grid paper, copy the figure, translate the figure, translate the figure 6 units to the right and 1 unit down. Now, first thing first, what we need to do, this is the shape the instruction is saying we should copy first. Again, the instruction is still there. Let us see. The instruction says to you guys, on the grid paper, copy the figure, translate the figure 6 units to the right and 1 unit down. Let us start. We need to start with the original shape. Now, normally I draw this line to give myself a direction. Just drawing this line, guys, it's not a must that you always start in the middle of your grid paper. You may start anywhere where you can be able to draw your shape successfully. Right, let us see. From the first line here, how many units did they skip to get to point A? So we will count. We will count, let us see, it's going to be, all right, 1, let us start with this one. 1, 2, 3, 4 will be our point A. Right. So I will start here as well myself. 1, 2, 3, 4, and in number 4 will be my point A. And then from point A to point G is going to be 1 and 2. 1 and 2 will be point G. And then from point G to point F, it will be 1, 2 downwards. 1, 2. This will be my point F. And then from point F to point E, it will be 1, 2, 3 units down and 1, 2 units to the right. So it will be, let me do again, 1, 2, 3 units down. So you may write it on the side, 3 units down. And we said from point F, 1, 2, 3 units down and 1, 2 to the right. And 2 units to the right. Now 1, 2, 3 units down, 1 and 2 units to the right. That will be our point E. Now from point E to point D, it will be 1, 2, 3, 4, 5 units to the left. So 1, 2, 3, 4, 5 units to the left. So it will be our point D. Now from point D to point C, we need to count. From point D to point C, it will be 1, 2, 3 units up and 1 unit to the left. So it will be 1, 2, 3 units up and then 1 unit to the left. This will be our point C. So can you see there, guys, I've just started with the points first. A, G, F, E, D, C. Now I need to connect my points so that I can see whether I've done the same shape as per the exercise. Now I will connect my points from point A to point C. And then point C connects to point D. And then point D connects to point E. And then point E goes to point F. Then point F goes to point G, and then point G and goes to point A. Right. So, guys, let us see. Are they identical? Yes. They are not. They are not. We made one mistake there. We forgot to put point B here. So there is a mistake. So this one will be wrong because this does not look like this one. Now we need to start again. Let us start again. Right. Now let us start. We started with point A. From here, from our edge, how many lines did they go? They said 1, or let us include this one. When we include this one, it will be 1, 2, 3, and number 4. So it will be 1, 2, 3, and number 4. And number 4, it will be our point number A. Then from point A to point G, it will be 1 and 2. This will be our point G. And from point G to point F, it will be 1, 2. Point F. From point F to point E, it will be 1. Okay, we wrote it here, guys. 3 units down and 2 units to the right. So 1, 2, 3 units and 1, 2. This will be our point E. And from point E, we go backwards now. And then how many units from point E to point D? We have counted 1, 2, 3, 4, 5. So it will be 1, 2, 3, 4, 5. Here it will be our point D. Then from point D to point B, so we go up 1, 2, 1, 2, 3. 1, 2, 3. So here it will be our point B. And from point B to point C, it will be 1 unit. 1. Therefore, we've got our point C there. After then, we connect them again. So we will connect them. C to B, then C to D, then D to E, D to E, and then E to F, E to F, and then F to G, F to G, and then B to A, B to A, and then A to G, A to G. Yes. You guys will become the judges now. Let us check. Is this the same as this one? Quite frankly, yes. Everything is as is in that. We've got point D, we've got point E, we've got point F, we've got point G, we've got point A, we've got point B, and we've got point C. Now, we may now go to the instruction. The instruction, what does the instruction say to us, guys? Let us read it again. It says, translate the figure. It says on the grid paper, copy the figure. We copy the figure. Remember, this is the original shape. So we could say this is an object or original shape. Original shape. Right. They say translate the figure 6 units to the right and 1 unit down. 6 units to the right. We may start with any point that we would love to translate. Let us start with, my option will be point E. Let us translate point E. 6 units to the right and 1 unit down. 6 units to the right. So it will be 1, 2, 3, 4, 5, 6 units to the right and 1 unit down. 1. So our prime E will be there. Remember, prime E must have this sign. 6 units to the right and 1 unit down. Let us translate point F. 6 units to the right, 1, 2, 3, 4, 5, 6. And then 1 unit down, 1. Then we will have our prime F. And then let us translate point G. 6 units to the right, 1, 2, 3, 4, 5, 6 units to the right. And then 1 unit down, 1. Then we'll have our new point G. And then point A, 6 units to the right, start from here. Remember, start from here. 1, 2, 3, 4, 5, 6 units to the right. And when 1 unit down, 1. There will be our prime point A. And then let us translate point B, 6 units to the left. 1, 2, 3, 4, 5, 6. And then 1 unit down, 1. Then we'll have our B prime. Let us translate point C, 6 units to the left, to the right, to the right. 1, 2, 3, 4, 5, 6. And then 1 unit down, 1. So our C prime will be here. C prime. And then let us translate point number D, 6 units to the right. 1, 2, 3, 4, 5, 6. And then 1 unit down, 1. So we'll have our D prime. Now, did we move all the points? How many are they? 1, 2, 3, 4, 5, 6, 7. And then let us see, we have translated 7 points. 1, 2, 3, 4, 5, 6, 7. Yes, we translated all the points. Now, after having translated the points, guys, we need to join them so that we can look at the shape, whether it does look that, and then the distance between the points are the same as the image, as the object. Now let us join point D and point E, and then point E goes to point F, and then point F is joined with point G, and then point G is joined with point A, and then point A is joined with point B, and then point B is joined with point C, and then point C is joined with point D. Therefore, this one is our image. Now let us take a look. Did we translate each point the way it was supposed to have been translated? Yes. Each point was supposed to have been translated 6 units to the right and 1 unit down. We have done that. And then are the side lengths equal? You may measure them, guys, just to be confident. Let us say, for example, we're going to measure point A and point B. When we see point A and point D, guys, it's 2 centimeters. Now let's look at the image. Does it correspond with the image? Yes, they do correspond. It's 2 centimeters as well. We may measure again point D and E of the image, which is 4,6. And then with the original shape, it should also be 4,6. It is 4,6 as well. So it means that we successfully were able to translate this shape. We've got the object here, we've got the image. Now, what is most important with the image, guys, is that please don't forget that these ones must have prime. This is A prime, this is A. This is G prime, this is G. This is C prime, this is C. This is B, this is B prime. This is F, this is F prime. This is D prime, and then this is D. Then this is E, and then this is E prime. So a prime will see, you will see it by that sign. So again, guys, as a word of advice, please, when we translate figures, first thing first, do not confuse your points. Please, please, please. As soon as you have translated each point, immediately write the name of the point or write the alphabet that is put next to that point, so that as you continue, you don't get confused and you don't make mistakes. You have seen that there was a mistake that was made when we were drawing this figure for the first time. So we did realize that no, there is something that is not looking the same as the one that was provided to us. You remember this? This is what I'm talking about. So we had a mistake, remember, because here it was going this direction and then this direction. Ours went just straight. So this was wrong. Now, this is how we fixed it. Because now we're able to see that from what the classwork was requiring us to do, it did not look like that. But now it looks exactly the same as what we have. And we also were able to translate it as per the instructions that were given to us, guys. Right. I believe after this, guys, the most important part is for you to be able to practice it. Practice it, guys. Copy, pause the video, just copy everything and redo it yourself. Mathematics is not a spectator subject, guys. We all know and we all understand. It seems simple when we do it together or when the teacher is doing it with you guys. But when you start doing it on your own, then you will see that, wow, you get to learn new things. You may even have your own methods of doing things simpler for you. So please, guys, practice. Do as I'm doing it. Make a pause, look at the video, and then redo what I've done. Right. Now let us move on. We are done with exercise number 2. Let us move to the last exercise of translation. In this one, the instruction says that to us, guys, describe the translation in each of the following diagrams. Describe the translation, guys. Now, let us look at the diagrams. These are the diagrams. These diagrams were already translated. We've got an original, we've got an image. We've got an original, we've got an image. We've got an original, we've got an image. So, for us to be successfully able to answer these questions or questions put in this form, the most important thing, guys, that we need to be able to do there, we need to observe what happened from S to S prime. So, for example, let us say A, which is this one. Now, in the first shape, which is A there, let us see. They say describe the translation in each of the following diagrams, the translation that took place. Now, we need to count what happened. So when we look there, let us observe from point S and S prime. How many units did they translate this point? Now we're going to count 1, 2, 3, 4, 5, 6, 7. So they translated it 7 units to the right. So that is point S. Let us look at point P. What happened to point P? They translated from here 1, 2, 3, 4, 5, 6, 7 units to the right as well. And then let us look what happened to point R. From here, 1. We don't count this one. Remember, guys, this is point R. So we start from the next line there, which is 1, 2, 3, 4, 5, 6, 7 units to the right as well. Point Q, from here, 1, 2, 3, 4, 5, 6, 7 units to the right. So it will be easier to us to say, okay, in diagram A, in diagram A, the figure or the original shape was translated 7 units to the right, which is the direction it took. So in diagram A, the figure or the original shape was translated 7 units to the right. That is our description. That is how we answer a question which asks us to describe. We observe the points, what was the movement around the points. Now, let us see. The answer for the first one, we say the figure is translated 7 units to the right. Now let us look at the second one, which is number B. Let us observe the translation that took place there, guys. We can see here we've got an original shape, and then here we've got an image. Now let us see from point S to S prime, how many units did it move? It moved 1, but we can see there, guys, it moved down as opposed to the first one. The first one, it moved to the right, and then this one, it moved downwards. So we will count how many units did it move downwards. We have already seen that it moved from here to here, so that is a downward movement. Now we will say, okay, from point S to S prime, it would be 1, 2, 3, 4, 5 units downwards. And then from point P to P prime, it will be 1, 2, 3, 4, 5 units downward. From point Q to Q prime, it will be 1, 2, 3, 4, 5 units as well. And then from point R to R prime, 1, 2, 3, 4, 5 units downward. So our answer there would be the figure is translated 5 units down. Right, let us look at the last one, which is number C. Now, what transformation or translation took place there? Let's start with point A. From point A, how was this shape translated? Can you see? We use the original to gauge the image. So we'll count 1. So before we even count, we check the direction it took. So it moved to the right and it moved upwards. So it moved to the right and then it moved upward. So it moved to the right and upward. So we can see that it moved to the right and upward. But now we need to count how many units was it moved to the right and how many units was it moved upward. Now let us see. It will be 1, 2, 3, 4, 5, 6, 7. Just straight to it. We can see it was moved 7 units to the right. So let us verify it first again. 1, 2, 3, 4, 5, 6, 7 units to the right. Was that all? Unfortunately, no, guys, it was not all. It was also moved 1, 2, 3 units up. So it was moved 7 units to the right and 3 units upward. Let us check B as well. 1, 2, 3, 4, 5, 6, 7 units to the right, 1, 2, 3 units upward. So from point B to B prime. D as well, 1, 2, 3, 4, 5, 6, 7 units to the right, 1, 2, 3 units upward. Point C, 1, 2, 3, 4, 5, 6, 7 units to the right, and 1, 2, and 3 units upward. So our answer would be, the figure is translated 7 units to the right and 3 units up. So we were able to describe translation. So guys, we've come to the end of translation. Translation, we did 3 parts. The first one, we were drawing it and translating it. And then the other part there, which is most important in the test and exams, it comes, we understand now when the question says, describe the translation that took place in each of the shapes. You just observe the shape, you carefully observe the direction first, that it took first, and then you start counting the number of times each point was translated. So that is very, very vital, guys. That is very important, that first of all, we check the point, the shape, the movement of the shape. Did it move to the right? Did it move to the left? Did it move upward, or did it move downward? Now, after having seen that, okay, it moved to the right and upward, or it moved to the right and downward, then we count the points. The most important part in your answer, it must be very clear how many units did it move. The first one, we said it was 7 units to the which direction? Right. Units, 5, direction, down. Here, units, 7, direction, right. Units, 3, direction, up. So the most important is that you provide the number of units it moved and also which direction did it take. If you are able to do that, guys, you will never ever encounter any problem with translation. Right. Let us now focus on reflection. Guys, I've provided you with those pictures there before we can do anything, so that we can have a picture in our minds or in our heads. What are we talking about when we talk about reflection? Reflection, in most cases, made an example with a mirror image. When you look yourself in the mirror, you would see who you are. You would see yourself facing, you are facing yourself in the mirror. This is also another typical example. When we look at this tree here, this is on the ground. This water shows us a reflection of a tree, but facing the other way. It does not face the tree. It does not stand as this tree. So it is facing the tree downward. Again, this bridge, this beautiful bridge that we see here, it is reflected in water in this direction. So this is a reflection of this tree, of this bridge. And then this is a reflection, this is a reflection, this is a reflection of this tree. This is a reflection of this bridge. Also, when you look yourself in the mirror, you will see your own reflection. So there are endless examples there, guys, when you talk about reflection. Now, but then we are not just going to observe on the pictures. We're going to do a reflection of diagrams, guys. We're going to do a reflection of diagrams. How do we make diagrams to reflect and things like that? But then the most important there, guys, that we have alluded on or we have touched on when we started is a line of symmetry. Let us start. Exercise 1, reflection. The question they say here to us, guys, when a figure is reflected, it is flipped or turned over. Flipped or turned over. Let me do a demonstration of flip, 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 flip. Right. This is an instrument. Now, this, I want to reflect this instrument. So I'm going to flip it. I did the reflection there. Or I can do it this way. Can you see? So that is what they are saying there when they say a figure, when a figure is reflected, it is flipped or turned over. the image that is produced is the mirror image of the original figure. So we cannot be flipping a triangle and then ending up with a rectangle. It cannot be the case. When we have flipped or turned over a triangle, our result should also be a triangle that is turned or flipped. It could not be any other shape. It should be the same shape that we flipped. The line of reflection is the most important. A line of reflection is like a mirror in which the original figure is reflected. So let us see. So a line of reflection is like a mirror in which the original figure is reflected. Now, they say to us, they copy the figures below and reflect the figures in the given line of reflection. Let us take a look on those figures. So these are the figures. These are the figures. Now, let us look at these figures. They said copy the figures and then reflect. Our line of reflection, we can do it on this grid that has been provided to us. The figures are already here. Now, again, guys, like we have done when we were doing translation, the most important part is that the first thing that you do, you move the points first. You reflect the points first. But the most important here, they don't tell us how many units you need to move each figure. Yours to do is to be very careful. That line of reflection will give you a guidance on what to do. Now, each point, we're going to count it, how far away it is to the line of reflection. For example, let us start with point G. Point G is 1 unit from the line of reflection. So our point G, when we reflect, it have to come this side, but it must be the same distance as point G on this other side. It must be the same distance. Now, from this line, it must be the same distance from this line. Now, let us see. It is 1 point from the line of reflection. Also, our point G will be 1 point, which means it will be here. It will be 1 point from the line of reflection. Now, here it will be our G prime. Then let us look at number, not the number, but the point F here. So when you check point F, you go along the same line where the point F is, but you check how many units it is far from the line of reflection. Let us see. From the line of reflection, it's going to be 1, 2, 3, 4 units to the left. So we are going to do the opposite, because it was 4 units to the left, 4 units to the left. We are going 4 units to the right from the point of reflection. So from here, we will say 1. Remember, we said 1, 2, 3, 4 units here. So we're going to count 4 units as well this side, but we are going this direction. We are going this direction. Now, I would say, okay, 1, 2, 3, 4. Now, this will be our point F prime. Then let us look at point H. Point H is on this line. Then let us check how many units is it far from the line of reflection. From the line of reflection, 1, 2, 3 units to the left. So we are going to do 3 units to which direction? Right, guys, because we are doing the opposite. The reflect, we are turning it. Right, so from the line of reflection, we're going to count 3 units. 1, 2, 3 units. There will be our point H prime. Then we can go to point C here. So let us see. This line is going to help us a lot. How many units is this line, is this point away from the line of reflection? From the line of reflection, it is 1, 2, 3 units to the left, and then we're going to count 1, 2, 3 units to the right, which is the opposite. So we will get our C prime. And then let us look at point D. Point D, we check how far it is from the line of reflection. How many units it is far from the line of reflection? Again, 1, 2, 3, 4, 5 units. Then we're going to count 5 units to the right. 1, 2, 3, 4, 5 units. There we'll have our D prime. D prime. Let me just make this D to be D. Right. Then the last line that we need to reflect there is the last point is point E. We're going to count how many units it is far from the line of reflection. So it's going to be 1, 2, 3, 4, 5, 6. So we're going to count 6 lines to the right. 1, 2, 3, 4, 5, 6. Therefore, we will have our point E prime. Now, these are only dotted points. Now, we need to join these points so that we can check whether we've got the same shape but facing the opposite direction. Now, let us see. Point F is joined to point G. So we're going to join point F with point G. So point F is joined to point G. Point F is also joined to point E. So we can go to point E and join it. There we are. And then point E, it is joined to point D. Point E, it is joined to point D. We do the same. Point E is joined to point D. And then point D, it is joined to point C. Point D is joined to point C. And then point C is joined to point H. And point C, point H. And then point H is joined to point G. Point H is joined to point G. Point G, point H. There we go. Guys, this one, remember, it was our original shape. This one is our image. Are they the same? Yes. But this one is facing this one. That is the mirror image of the original shape. So that is how we do a reflection. Again, we've got another opportunity to do the second one. Again, what is most important? A line of reflection will give us exactly what we need to do. First thing, let us check point J. How far is point J to the line of 1 unit? So we're going to do our point J here. Point J. Then we come to point K. How far is it from the line of reflection? Is this side is 1 unit, so it's going to be 1 unit here. This will be our point K. And then point C, which is this one. How far is it from the line of reflection? It will be 1, 2 units. So we're going up. So we're going to go units down. 1, 2 units down. 1, 2. And this is our point C. Point D. How far is it from the line of reflection? 1, 2, 3, 4. So we're going to go 4 units down. 1, 2, 3, 4. So here we'll have our D prime. Remember, this is C prime and K prime. Then point E. How far is point E to our line of reflection? We will say, okay, 1, 2. So we'll go again the same direction, 1, 2. So this will be our E prime. Point F. How many units away from the line of reflection? 1, 2, 3, 4 units. Now we'll count 4 units because it went up. We'll count 4 units down. 1, 2, 3, 4 units. Then it will be our F prime. Then G, how many units away from the line of reflection? 1, 2 units. So we'll count, because it went up, we go down. 1, 2 units. So this will be our G prime. Then H, how many units away from the line of reflection? 1, 2, 3, 4 units. So we'll count 4 units down. 1, 2, 3, 4 units. This will be our H prime. Right, the last line is L. L, how many units away from the line of reflection? 1, 2. We're going to 1, 2 as well. So this will be our L prime. Guys, if you see these points now, we have not yet connected them so that we can see the reflected shape. Now we need to connect. K is connected to J. Goes K to J. And then K again to C. K to C, K prime, C prime. Then C prime to D prime. C prime, D prime. D prime, E prime. D prime, E prime. E prime, F prime. Go E prime, F prime. Then F prime to G prime. F prime, G prime. G prime, H prime. G prime, H prime. The H prime to L prime. L prime to H prime. Then J prime to L prime. There we go. Voila! We are doing it, guys. So you can see we've got our reflected part. They cannot face the same direction as translation. Remember, here we are not translating, we are reflecting. So the shapes are the same sizes, they are the same shapes, they are same sizes, but they are not facing the same direction. The other one is facing this direction, then the other one is the mirror image of the original. So here we've got the image. Here we've got the original shape, which is the object. So these are the shapes that we reflected, guys. So the most important, guys, again, with reflection, the most important part, guys, is the line of reflection. The most important part there, guys, is the line of a reflection. A line of reflection is a determining factor in terms of how many points, how many times you're supposed to move the points away from the line of reflection. Each point will give you exactly how many times it was moved so that it formed a mirror image of the original shape. So again, guys, this is now where translation and reflection differ. Translation, we move the points as per the instruction. The instruction would say maybe 5 units to the right, 3 units downward. We know the instruction will be given. But with the reflection, there won't be an instruction given to us. The most important part for us to identify is the line of reflection. Line of reflection will tell us, will show us how many points is far. We are moving the points, how many times is far, or how many lines or units is the point far from the line of a reflection. So that one is the most important part. That translation, we are given the number of units to move the shape, the points of the shape. Now, in reflection, we are not given that. What is given to us is a line of reflection. A line of reflection will definitely give us a direction, what to do there, guys. Right. Now, let us see. In exercise 2, it says copy copy the following diagram, draw the line of reflection. All right. So the first one is this one, is this diagram. A line of reflection has already been provided for us there. Now you can see this one is a bit challenging because it is diagonal, it is not straight. It's a diagonal line of reflection. But now what we need to do again, guys, that dotted line of reflection shows us how many each point is far from the point of reflection or line of reflection. Right, let us see. We've got point L, point K, point O, point N, point M. You may start with any point that you would love to start with. But here, because our line of reflection is diagonal, we also have got to move diagonal way when we move the points. For example, let us look at point O. How many points is it far from the line of reflection? So we're going to count diagonally. So let us see. Point O, it will be 1, 2. 1, 2 away from the line of reflection. So for us, if we want to do point O, we will count 1, 2 units. We will count the units to this side, away from point O. Same applies to point N. Point N, how many units are far? It is 1 from the line of reflection. So because it went up, we will go downwards, diagonal this side. Same applies to point M. The same applies. Can you see? So we move according to how far it is the point from the line of a reflection. Now, check there the other one in number 2. Number 2 says copy the following and draw the line of reflection. Now here, there has to be a line of reflection. A line of reflection, remember, is similar to a line of symmetry in terms of how far is each point from the original shape. So here we've got an original shape, here we've got an image. So our line of reflection, it should be a separating line that each point is equal in terms of movement but different directions. Now, for example, you see we've got E here and E prime here. There is only one point, meaning that our line of reflection, without even hesitating, it could be between these A's. Not A's, E's. So our line of reflection is there because from the line of reflection, E is 1 point away, and then E prime is also 1 point away. F is 2 points away, and also F prime is 2 points away. G, it is 1, 2, 3, 4 points away, and then G prime is also 1, 2, 3, 4 points away. So yes, this will be our line of reflection. Can you see? Right. With this one, it will be our diagonal line of reflection. We've got the original, we've got the image. We need to decide where would our line of reflection be. Remember, our line of reflection must be able to cut our shape in the same distance because it has to be the same. It must be 2 equal parts. It must be 2 equal parts away from each other. So when we cut it here, when we do our measurement with the ruler or we size the shape there and check how many times is each point away from the line of reflection. For example, we've got G prime and G. If we do the point in the middle of them, they will be moved the same distance but different direction. So we may say, for example, our line of reflection could have been there, or it is here. Our line of reflection, it is here. Because, for example, when you check, from the line of reflection is 1 point to G, and from there is 1 point to G. From the line of reflection, it is 1, 2 points to H, 1, 2 points to H. From the line of reflection to I, 1, 2, 3, 4, 5. From the line of reflection, 1, 2, 3, 4, 5, which is line number L. So our line of reflection, again, guys, it separates the points in such a way that the distance between the points is the same, but different directions. All right. Now let us look at number C. Number C. Now in number C there, guys, we need to determine, we've got the original shape, we've got the image. We need to draw our line of reflection. Our line of reflection will be a line that will make sure that the points, they are the same distance apart from the line of reflection. Let me repeat that again, guys. Our line of reflection, when we draw it, it must determine, or it must be a line that will show that each point is the same distance afar from a line of reflection. For example, if we put our line of reflection on this line, for example, if we are putting a line of reflection here, will the points be the same distance from the line of reflection? No, it won't. So we need to be able to check a line of symmetry of the shape first. We can see in this shape, our line of reflection, our line of symmetry, it could be here. It could be here, because there must be equal distance afar from each shape and from each point as well. All right. Now, first of all, what do we need to do? We can count the points. How many blocks are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our line will be, when it cuts it, it must be 10 this side and 10 this side. Now let us see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Meaning, when we draw our line here, we'll have 10 this side and 10 this side, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, our line of reflection would be here. So this will be our line of reflection. But again, we need to verify that what we have done is true. Let us check whether each point is the same distance apart. This is the line of reflection. How many units to point B? 1, 2 units. This is the line of reflection. How many units to point B prime? 1, 2. Correct. Again, this is the line of reflection. How many units away from point A? 1, 2, 3, 4 units. All right. This is the line of reflection. Must be 4 units to A prime. 1, 2, 3, 4 units. So yes, that is the correct way of doing our line of reflection. Right. All right, guys. Now we are moving to the last part, which is rotation. Rotation, guys, I've provided you with those examples. Rotation is when we move the shape. Either we're going to rotate it clockwise, or we're going to do it anti-clockwise, or they normally say counter-clockwise. Counter-clockwise, it means anti-clockwise, opposite of the way the clock is moving. Right, those two pictures there, we've got a picture of a cell phone being rotated, and then we've got a shape there, a graph there showing a clockwise movement and an anti-clockwise movement. Right. Exercise 1, we are taking rotation now. It says, when a figure is rotated, it is turned in a clockwise direction or in an anti-clockwise direction around a particular point. This point is called the center of rotation, and it could be inside the figure or outside the figure. Let us work it out. For example, let's say rotate triangle ABC 90 degrees about point P. Point P in this case, is our center of rotation. Point P is our center of rotation. On a grid paper, all right, no, I'll move to the second one. Plot the image of each vertex on a grid paper, right. Let us see. This is the shape we are talking about. This is the shape we are talking about. Now, let us see. Again, guys, let me reread the instruction as per this. It says, rotate the triangle ABC 90 degrees clockwise. Clockwise, it means that we are moving this direction as per the clock. So it is clockwise. Plot the image of each vertex on a grid paper. Right, this one is the original. They said, okay, remember the image point must be the same distance from point P as the original point. The original angle that is formed between the line connecting an original point to point P and the line connecting its image point to point P must be the same as the angle of rotation. In this case, it must be 90 degrees. Okay, then lastly, join the image points to create triangle A prime, B prime, and C prime. Right, let us start first by drawing that triangle. Alright, let me start. I will put my C, my original C, I will put it here. Let me put it the way it was put here. This will be my original C. And then I'm going to count how many units. Right, this is my original C. Right. And then 1, 2, 3, or to A, it will be from C, it will be 1, 2 up, and 1, 2, 3, 4, 5 units. So 1, 2, 2 up. So from point C, 1, 2, and 5 to the right. 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. So my point A will be here. And then from point A to point B, 1, 2, 3 units. Then I'm going to go 3 units down as well. 1, 2, 3 units. This is going to be my point B. Then from point B to point P, which is our center of rotation, will be 1, 2 units down and 1 unit to the right. So it will be 1, 2 units and 1 unit to the right, which is P. This is our center of rotation. Right. Now we need to connect the points. Connecting point A and point C. Connecting point C with point B. Then I'm connecting point B with point A. Right. All right, guys. After having done that, the most important part here now is that these resources are going to help us. We'll need to use a protractor, we need to use a ruler, we can either use as well as a compass. So we'll use this compass, a ruler, and a protractor. Remember here we talk about angles. One word of advice, guys, we need to do the dotted lines between point B and the center of rotation, which is point P in this case. So let us draw the dotted lines. Right, and then again we need to measure the distance in centimeters between point B and point P. So here we find that it is 2 centimeters. 2 centimeters. Right. Then, remember the instruction says to us, rotate. The instruction says to us, rotate 90 degrees clockwise. Clockwise. So we're going as the same as the clock. Now the most important part here, guys, is the way in which you're going to put your protractor. Remember, our protractor will be put in this direction, not this direction. Why? Because we are not moving anti-clockwise. We are not moving from 0 this direction. We are moving clockwise. Now, the most important part again is the center of your protractor there. The center, which is this part, and this line must be straight to point B. Straight to point B and the center here. Now, we are told to rotate it. Rotate it 90 degrees clockwise. So it means we are moving this direction. So we are going to rotate it 90 degrees. So this would be 10, 20, 30, 40, 50, 60, 70, 80, 90. 90 degrees. We make our point there. We make our mark there. 90 degrees. Let me put it like that. Right. Then going to draw a line between here to there with a pencil. And then you can either use a ruler, whereby you'll measure the distance. Remember the distance between point P and point B was 2 centimeters. So we also need to put it 2 centimeters long. So it means that it will be 2 centimeters long. So our point B will be here. So our point B will be here. Forgive me, guys, for having written that. So our point B will be here. Right. Then, or you can use a compass. You can move the arms of the compass from here to point B. From here to point B, you can see there, and then you can do your arms there. Now, if you made the arms there, it means that that is the length of your point B. So we will have our B prime here. Then we need to rotate point A. Remember, we rotate each point. But before we rotate point A, we need to make a line from the center of rotation to point A. From the center of rotation to point A, we need to make a line. And then after having made that line, we take our protractor, we measure the angle. Remember, first, the center is point B, it's point P, which is the center of rotation. So our protractor must be there. And then on point A there, that line shows us the distance, the straight point of point A there, where we're going to start counting. So from here, we count 90 degrees. Right. Now, it will be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. So here we will have our 90 degrees. And then we draw a line. May make it a dotted line or a straight line. It won't be a problem that much. Then what we do, we measure the distance between the point of rotation to point A. So from point of rotation to point A, it is 4.5 centimeters, 4.5 centimeters, which means our point A will be also 4.5 centimeters long from the point of rotation. So it will be 4.5. It will be here, which is here our 4.5. So this will be A prime. Then we need to rotate point C. But before we rotate point C, we make our line. You may make a line with a pencil, or you may make a dotted line. We make a dotted line from point C to our point of rotation. Now, after having made that, we take our protractor. Our center must be there, and then 0 must be facing our point C, like this. Remember, guys, we are moving clockwise. So here, it must be the same. It must be on the same line. Our 0 must be here on point C, and then our center of the protractor must be at our point of rotation. And then we need to rotate it. Remember, we are rotating it clockwise, 90 degrees. So our 90 degrees is here. Our 90 degrees is here. Therefore, we may make dotted lines or straight lines with a pencil. The choice is yours. What do you do afterwards? You measure the distance between the point of rotation to the original point. So from the point of rotation to the original point, it shows that we have 5.5 centimeters. So our point C will be 5.5 centimeters away from point of rotation. So we'll go there. It will be here. It will be here. Then here we will have C prime. Here we will have C prime. Right. Guys, after we have done that, the most important part now is for us to join the points. Now, let us join the points. We've got A prime, B prime, and C prime. Remember, the first dots there were showing where is 90 degrees. But the second dots, it is the distance away from the point of rotation. Now, when we join from the distance. Let's see, our point is there. Then A prime. And then C prime. So the other important part is that the distance between our point of rotation and B prime must be equal. So in this case, they are 2 centimeters, 2 centimeters. That is how we do a rotation, guys. Right. But I think this writing might have confused some of the things, might have made matters be complicated or some sort. But let me, because I've got another activity that we're going to do together, guys, where we are rotating again. Don't worry. Here we were rotating here we were rotating clockwise direction. So when we say clockwise, it means that we're moving this direction. So we were rotating clockwise. So this one is the object or the original shape. Then this one is the image. So after you are done drawing those lines, after you are done connecting the points, you may erase these lines. They're no longer important for you. They were important while you were measuring and rotating the shape. But now, since you have finished, then you can erase them. You can erase them, and then we may take them out of the picture so that we can see our own shape being rotated. There we are. Right. Now, let us look at the next exercise. The next exercise says, on a grid paper, rotate triangle XYZ 90 degrees anti-clockwise. 90 degrees again, anti-clockwise about point F. So point F will be our point of rotation. Anti-clockwise. Right, let us look at it. Here it is, that activity. It says, let us read it again. On grid paper, rotate triangle XYZ 90 degrees anti-clockwise. Now, when they say anti-clockwise, it means we are going to be moving the opposite direction of the clock. So, anti-clockwise. Right, the first thing that we need to do, guys, is to copy this image. Is to copy this original shape on our grid paper here. Right, let me do it. Let me see X, point X, point X, point X. 1, 2, 3, 4, 5, 6, 7, 8 units, right? 1, 2, 3, 4, 5, 6, 7, 8 units. So this is where my point X will be. Then point X, from point X to point Z, it will be 1, 2, 3, 4 units down, 1, 2, and 2 units to the right. So it will be 1, 2, 3, 4 units down, and 2 units to the right, 1, 2. This will be my point Z. This was my point X. Then from point X to point Y, it was 1, 2 units down, 1, 2 units to the left. 1, 2 units down, 1, 2 units to the right. So guys, here is not an instruction that you must always start with what I started with. You may start with X, you may start with Z, you may start with Y. Right, and then center of rotation is point F. Let us see how many units from Y, because Y is our point of reference in this case. Now let us count is 1. From here it is 1, 2. Right, it will be 1, 2. Number 2 there, it will be point F. Point F, which is center of rotation. Now let us connect the points there to form that triangle. So we're going to connect point Y and point Z, and then we connect point Z with point X. Then we connect point X with point Y. There we go. Right, so we do have connected our points, but this is our center of rotation. So the instruction says that to us, we need to rotate this shape 90 degrees anti-clockwise. Right, so again, we're going to need a protractor. We're going to need a ruler, or you may use this instead of this. You may, between these two, you use one. You can use a ruler, or you can use this one, or you can use them both if you like. But mostly I prefer to use a ruler. So I will just use a ruler, guys, with you. Now, let us see. The first thing that we need to do, guys, is to rotate. But before we rotate, in this case, this line is done as just this. Now, when we rotate this one, it says we need to rotate it anti-clockwise. Now, anti-clockwise, it means we're going to move the opposite direction. We're going to place our protractor like this because we are moving this direction now. So we are moving this direction. We are no longer moving that direction. So we move this direction anti-clockwise. So we're going to start with point Y. So remember, when we rotate point Y, we're going to put the center at the center of rotation, and then the 0, it must be at point Y. So I'm going to use my inside numbers in this case when I count. So I'm going to start here. This will be 0, 10, 20, 30, 40, 50. Can you see I'm moving the opposite direction of the clock? So it is anti-clockwise. 10, 20, 30, 40, 50, 60, 70, 80, 90. So 90 is here. So the first thing there, I'm drawing a dot. Right, guys, again, I put my protractor, my center of my protractor must be at the center of rotation. Remember, always, your center of your protractor, your center, this part, must always be at the center of your point of rotation. And when you start with the first point, this line, it must be straight to that line, and it must always be starting from 0. It may not be like this. You cannot put it like this and say you are rotating. No. Just make sure that the protractor is put, the center of the protractor is there, the center of rotation, and then the first point that you're going to be rotating, it must start from 0. It must be straight here. Now it must start from 0, and then you rotate it 90 degrees anti-clockwise. And then when you are done rotating and putting the first point there, remember again, guys, do a dotted line. Do a dotted line with a pencil. on your grade paper, do a dotted line. This line, it will help you, right? But before we put our point, guys, remember, this distance is not the same as this distance. Our point must be the same distance as this one. So this is where you can either use your own compass or you can use a ruler. So this is where you can use this or you can use this. Choice is yours, guys. But most importantly, when you are using this one, make sure that when you open the arms of your compass, they are same distance from the point of rotation to your first point that you rotated. So they must be same distance. Now let us take a look. From here, you open the arms up to where the first point is. And then when you have done that, then you can point your compass there, and then you can make your arc or your semicircle. This shows you where your point is supposed to be put. Can you see? So this will show you where your point is supposed to be put, or you're supposed to put it. So in this case, where they intersect these lines here, it will be our prime y. Now, or when you are using a ruler, this is what you do when you use a ruler. You measure the distance between the point of, or from the point of rotation to the first point that you just rotated. So from here to here, it is 1,9, almost 2 centimeters. It must be the same distance between these two. It's also 1,9. You can see there, guys. Also 1,9. So it must be the same. So you either use the one you like best. Now we have just rotated the first point anti-clockwise. Rule number 2, before you rotate the second point, the most important part is to make a line from the point of rotation to the second point that we're going to move. Like in this case, we're going to move point X. So we must put a line from the point of, it may be a dotted line or a straight line, from the point of rotation to the point where you are moving, where you are going to be rotating the line. So it must form a straight line like this or a dotted line like this. Now after having done that, guys, that is my dotted line. Step number 2, I take my protractor and I'm putting it. The center must be at the center of rotation. The 0 must be straight to the point that I'm about to rotate. So the center must be at the center of rotation, and the 0 must be in this point that I'm about to rotate. If my 0 is there, then I can now start to rotate it. Remember, the instruction is to rotate the point 90 degrees anti-clockwise. Again, we are moving this direction anti-clockwise. Now I'm going to count here 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees anti-clockwise. 90 degrees anti-clockwise. Then when you are done putting that point, you take a ruler, you are going to do a dotted line from that 90 degrees to the center of rotation. From that 90 degrees to the center of rotation, just do yourself a dotted line. That is step number 2. Step number 3 is to measure the distance using either your compass or using your ruler. Now let us say, for example, for argument's sake, we are using a ruler. A ruler will measure the distance from here to that point. Now the ruler there shows us that the distance from the center of rotation, to that point, it is 4 centimeters. It is 4 centimeters from here to here. It means our point must be from the point of rotation, must be 4 centimeters away. So we take this ruler, we coming to that dotted line of ours that we just drawn. We measure 4 centimeters. We measure 4 centimeters. Now from here, the point of rotation to here, 4 centimeters is here. Now if 4 centimeters is there, we do that line. I know now that my point is coming here. Now which means my x prime is there. Right? Then again, guys, I moved 2 points. Y prime is there, and then x prime is there. What do I need to move is point Z. Point Z is going to be a bit simpler for me because, guys, already there is a line according to my graph paper there. There is a line that is straight for me. So I don't need to make a dotted line. Or you may make a dotted line just to ease up everything for your own self. Make a dotted line first. Then after made that dotted line, step number 2, what do? You take a protractor. You take a protractor, then there we go. Remember again, the center of the protractor must be at the center of rotation or at the point of rotation. Now, when you are done doing that, you must make sure that you are about to move point Z. So it means the 0 must be there at point Z. Then we start anti-clockwise again. So we say 10 using the inside counters, 10, 20, 30, 40, 50, 60, 70, 80, 90. So our 90, because we were told to move it, to rotate it 90 degrees anti-clockwise. When we say anti-clockwise again, we are moving this direction. So we were told to move it 90 degrees anti-clockwise. So there we are, 90 degrees anti-clockwise. After having made that point, again, you may take it and make a dotted line. Now, when you are done making the dotted line, step number 3, you cannot put your point here. Remember, guys, it must be the same distance from the point of rotation. Now we need to measure the distance from the point of rotation to that point. From here to here. So we see from here to here it is 3,6 centimeters. So we will also measure 3,6 centimeters from the point of rotation to determine where our point will be. It will be from here, then it's 3,5, then it's 3,6. So our 3,6 is here. Now, that means our point of point Z prime will be here. Now, guys, when we are done, remember I did put all my points. Now what do I need to do? I need to connect them. Then I'm connecting from point Z to point Y prime. Then from point Y prime to point X prime. And from point X prime to point Z prime. Right. So this is our rotated triangle. It is rotated 90 degrees anti-clockwise. Just take a look at that. So that is how, guys, we rotate shapes. We may rotate them clockwise, we may rotate them anti-clockwise, we may rotate them per the angles that are given to us, 45 degrees, 90 degrees, any measurement that has been given to us to rotate the shape. So this is, if we had an image paper, it would have been able to show us that this has been rotated 90 degrees anti-clockwise. Right. So, guys, this, all right, on a grid paper, the last activity, it says on a grid paper, rotate rectangle 45 degrees anti-clockwise around point D. Around point D. Let us have a look at that one. Right. So this is the rectangle they are talking about. So we are told to rotate this rectangle 45 degrees anti-clockwise around point D, around point D. So we don't have, in this case, point D will be our point of rotation. So when we rotate this point 45 degrees anti-clockwise, it means that we're going to move this direction, right? All right, so let us start. Step number one, guys, because it's a rectangle in this case, you can start with whichever point you would love to move first. My preference would be to move point C. To rotate, not to move by the way, to rotate point C. So I'm going to put my protractor like this. Remember, point of rotation in this case is point D. We are told to rotate it around point D. So point D is here. It's here, point D. Can you see that point D is here? And then the center must be in point D, and then the 0 must face the first point that I'm supposed to rotate, which is point C in this case. So I'm told to rotate it 45 degrees anti-clockwise. So when I'm rotating it anti-clockwise, remember anti-clockwise, we're moving this direction. Now I'm going to move 45 degrees, 10, 20, 30, 40, and then 45 will be between 50 and 40. In this case, my 45 degrees will be here. So I'm going to make that point a little bit bigger. Then, after having made that point, what do? You do a dotted line. Join the dotted line to the point of rotation. Right. After having done that dotted line, what do? We measure the distance from the point of rotation to that point. In this case, our point of rotation is point D. From point D to point C, what is the distance? The distance is 6,5. 6,5, 6.5, 6,5. So my point must also be 6,5 from the point of rotation. So in this case, I'm putting it here, then I'm going to count 6,5. So 6,5, when I move along this line and going all along enough so that I can identify my 6,5, and my 6,5 will be here. My 6,5 will be here. Now, that means my point C prime will be here. Right, I've rotated the first point. Now, the question would be, I have rotated point C. Now I need to rotate point B. Again, the most important part, remember this one was easier because it was straight, it was on a straight line. This one is not on a straight line. So we need to draw a dotted line from this point to this point, so that we can be able to put our protractor and measure and rotate it the way we are told to rotate it. So we put the dotted line that goes from the point of rotation. Remember, this point in this case is our point of rotation. From this point to this point. After having that dotted line, guys, what do? We take our protractor, and then we're going to put it. Remember, it may not be like this. When we put it like this, yes, it is at the center of the point of rotation, but the zero is not moving. We are not rotating this point, so it may not be like this. The zero must face the point that we are rotating. Now we need to move it along the point that we are about to rotate. So the center, which is the point of rotation in this case is point D, it is there. And then the dotted line now helps us to show that the point D that we are looking for, it is here. So the zero must be facing this point. Now we need to rotate it. How many times we need to rotate it? 45 degrees anti-clockwise. Now we count 10, 20, 30, 40. Then 50 is here, 40 is here. Between 40 and 50, that will be our 45. Then I'm going to put my dot here. Going to put my dot here. Now, when I put my dot here, that shows my dotted line. Then I can do my dotted lines there. Now, after having drawn those dotted lines, second step, measure the distance between the point of rotation to the point that you just rotated. In this case, we just rotated point B. So I'm going to measure the distance between point D to point B. In this case, we rotated point B. Yes. So the distance between point D and point B, it is, let us see guys, it is 7,4, which is 7,4 centimeters. So I'm going to make sure that my point should be 7,4 centimeters away from the point of rotation. 7,4 centimeters away from point of rotation. 7,4 centimeters. Now let me check. It means there I must increase, make this line a little bit longer, because I know this is where my 45 degrees is. So 7,4 will be here. So I'm going to put it here. Therefore, my point B will be here, which will be my B prime. Right. And then I need to rotate my rotated point C and rotated point B. I'm supposed to rotate point A. Okay, what do? I put my protractor here. The center must be at the center of point of rotation. Then 0, in this case, 0 is facing point C. I can see that I'm not using point C. 0 must face point A. So I'm going to rotate it and put it this way, and then make sure that my center of rotation, my center of the protractor is at my point of rotation. So therefore, my point that I'm supposed to rotate is point A. Yes, I've got 0 there. Now I can rotate it 45 degrees anti-clockwise. Anti-clockwise, this direction, anti-clockwise. Now, from here it is 0. I'm going to count 10, 20, 30, 40, and 50. So it means my 45 is between 40 and 50, which would mean this line. Now, if this is the line, then I'm going to put a dot here. That is 45, my 45 degrees. Now I put my 45 degrees here, then I put a dotted line. Right. After I've put that dotted line, guys, I need to measure the distance between my point of rotation to that point. In this case, my point of rotation is point D. Point D is my point of rotation. The distance between point D and point A, it is 3,6. So therefore, my point will be at 3,6 distance away from point D, 3,6. So which means will be 3,5, 3,6 is here. So 3,6 is on that line that I just drawn. Then it means there is going to be my point A prime. Now, guys, I moved all the, I rotated, not moved, very sorry, forgive my language there, guys. I rotated all the points. I rotated point C to C prime. I rotated point B to B prime. I rotated point A to point A prime. Now, remember, point D was a center of rotation or a point of rotation. Now, after I've done my rotated my points, I need to connect them. Now, I'm going to connect them. Point C must be connected. Remember, point C was connected to point D. So point C will be connected to point D. Then point B was connected to point C. Point C was connected to point B. Point B was connected to point C. There we are. Then point A, B was connected to point A. There we are. Then point A was connected to point D. There we are. Now, this blue one is our image after rotation. This red one was the original shape. Can you see that, guys? So that means we can rotate a point, we can rotate a shape around a certain point. It may be, like we have said before, it may be inside the shape or it may be outside the shape. Like in this case, the point of rotation there was the point D, one of the points in the shape that was given to us. So we needed just to rotate it 45 degrees. And you can see we have rotated it 45 degrees anti-clockwise. We are not moving the clockwise direction, we're moving anti-clockwise. So guys, that is that. Again, guys, with rotation, you need to have a protractor, you need to have a pencil, you need to have a ruler for measurements, and again, we need to identify our point of rotation. Our point of rotation is always going to be given to you. You will always be told which one is a point of rotation. It may be one of the points in the shape, or it may be one of the points outside the shape. You may be given a point outside the shape or inside the shape. So just be careful. And then just read thoroughly, just make sure that, all right, the instructions are very clear for you. You know what to do. One. And then number two, remember, first thing that you do when we rotate a shape, or when we rotate a point in a shape, first point, you will decide which point you want to rotate first. But the first point that you rotate, the center of your protector must be, the center must match with the center of rotation. And then 0 must face the upside, and then if we were moving anti-clockwise, it was going to stand, if we were moving clockwise, it was going to stand like this. Anti-clockwise stands like this, your protractor. And again, the 0 must always be facing the point that you are supposed to, you are about to rotate. That is number one. Number two, don't forget, the distance between the point of rotation and the shape that you just, the point that you just rotated must be equal. That is very crucial, guys. The distance between the point of rotation and the point you just rotated must always be maintained the same distance apart. That is number two. After having measured the angle that is supposed to be rotated, remember, it is not yet a point as yet. You just put a dot so that it can give you a direction that you're going to use. And number two, take a ruler, measure the distance between the original shape from the point of rotation to that point, and then make sure that you move it along that line. Right, guys, thank you very much. It has been a plum, pleasant pleasure as well as a privilege to host you grade 7s. Hopefully, I added some understanding in transformation geometry, guys. We are not yet finished with the transformation geometry. We will meet again for the last part of this topic, which will be doing enlargement and reductions. But for this one, guys, please revise, do the translation that we did together with you in the video, do the reflection that we do together, do the rotations, please, rotations. And the most important part there, guys, is that practice, 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 then you will master it. The more you practice, the more you'll master. And the nice thing about this is that it's a video. You can pause it and check the steps that I followed when I was rotating, translating, or reflecting. Thank you.